by Monday whether the course is going to be expanded and by how much. So you'll have a good idea if you're in by then. Also, don't get stressed out too much about the homework. I have not taught you how to do most of the stuff that you need to be able to do that, and I'll definitely adjust the due date appropriately to make sure you still have enough time to get it done. So like, don't kill yourself trying to make it get done by whatever it's supposed to be due next Friday. That was just an estimate. Obviously, we're going a little bit slower than that, so don't get too caught up in things. Also, again, if you don't feel comfortable asking questions during class, you can use the poll everywhere to submit a question that way. Any questions before we get started today? The new due date would give you about a week's worth of time, maybe half a week to get it done from then. Yeah. Like the cap right now is like 200-ish, and there's like 300-ish or something like that. Okay, so calm down. We're starting, and you actually want to get through this so you can learn something. So, next thing that we want to talk about is switch statements. Switch statements are very closely related to if statements, but they're a little bit simpler. First thing that I want to point out is these statements right here, lines 41 through 43. They're defined statements. These are commands to the C preprocessor, and they're saying, I want to define the symbol red to have the value 0. And so now later on, whenever you use the word red, the compiler will replace it with 0. We'll just substitute every occurrence of red with 0, every occurrence of yellow with 1, and every occurrence of green with 2. So this can be a decent way of giving meaningful names to some constants if you have to. But in general, it's better to use constant variables, which we'll eventually hopefully get to later on, and how they work. And for these examples, it would be even better to use enums, but I don't want to introduce too many topics at once, so you'll see enums later on and how we could do this in a better way. So just red 0, yellow is 1, green is 2. So here's what a switch statement looks like. It's switch, and then on the variable you're interested in checking its value, curly bracket. Then you're going to have a bunch of cases. Each case is going to be comparing the value of the tested variable against the value over here. So in a lot of ways, it's like writing the an if statement just to check for equality. So case yellow means if light color equals yellow. Case red, if light color equals red. Case green, if light color equals green. Then you have a semicolon, whatever code you'd like to run. And then when you're done with that case, you need to make sure that you hit put break in there to leave that case because you're done, and you will leave the overall switch statement. Finally, you can have this default value for if none of them match. It needs to be at the end, and then you'll run this basically else statement. So a lot of ways it's like if light color is yellow, else if light color is red, else if light color is green, else print the value. When you're doing a switch, you can't do switches on doubles. You can only do switches on integers and characters, which is kind of a weird limitation. So I tend not to use them that much because of how limited they are. But they can be useful sometimes for expressing that logic. If you do forget the break statement, it's not a syntax error. It's completely legal. And what will happen is after it does this line of code, it'll do the next line of code of the next case. No comparison, it just goes and does the next one. So I'll show you an example of forgetting the break statements and how that can lead to some weird behavior. And there are, though, also sometimes you might not want to have breaks if you want to do the exact same thing for multiple values.
What's the advantage?
The question is, what's the advantage of this over else if? You maybe sometimes get to write a little bit less. You don't have to keep saying else if equals value. You can just say case value. That's really about it. There's not really any huge advantage over the switch statements over if statements. Sometimes it might like encode your thinking a little bit better though. Like, you know, this is the case that we want to do if it's red or green or yellow, right? Handling this light color. So a lot of times it might just be it better encapsulates the way you were thinking. Correct. Everything that's not red, green, or yellow is handled by the default. And remember, red, green, and yellow are just these numbers. So anything that's not 0, 1, or 2 is going to end up in there. Yeah. So the question is, why would someone use define instead of constants? The define values are available to the C preprocessor. And so if we're doing some more complicated things, like there are preprocessor like if statements, you can base them around the values of the define, where you couldn't do it on the value of a constant integer or any other constant variable type. So sometimes you might have it, and you'll see when we talk about header files later on, you'll see like the if statements for the compilers, or for the if statements for the guards for the preprocessor. Sometimes you might be, like if the platform I'm running on is Windows, I want to do this code. But otherwise, if the platform that I'm running on is Mac, that I was compiled was for Mac, I want to do this other bit of code or turn these pieces of code on and off based on the platform you're on. You can do that with pound defines. But you couldn't do it with a constant variable. But for like normal switch statements, you would want to use constant variables for specifying your values. But also one of the weird things is in the case statements, you cannot use another variable to compare it against. So like if I've had some other integer named like x, I could have like int x here, that integer x, which is annoying. So I have to kind of do the pound defines, but I'm not using the enums. Anything else? Yes. So the question is, if you put in a number like 0, or like if we put like yellow is 1. So if you put in 1 in that spot, you get the exact same behavior, but it's a lot easier to understand with the names, right? So we're trying to give these like not really like intuitive constants some meaningful names to use in our programs. So with pound defines, they have no type, which is why they can be unsafe. So there is no type on them. They just literally do a text substitution. So anywhere this symbol red appears in my program, it literally just replaces it with the value 0. So it has no type. So if we define red as 0.0, it wouldn't work because you can't have doubles there. Okay. So here's an example of some code where we didn't put the breaks. So if somebody enters in the light color as being yellow, we'll print slow down, but because we don't break, we fall through the red case. We also print stop the car. But then because there's no break statement here, we'll fall through to the green case and print go through the intersection. This is like some very bad advice for when you handle the yellow lights, like go faster, no, go slower, no, stop, right? And then it would also, since there's no break statement here, also fall through to the default case. That's a really common mistake to make when using switch statements, is forgetting the break to leave the case when you're done with it. But sometimes you might want to have that behavior. So right now, we're trying to figure out if the person gets passing or not passing the class. So if the letter grade is A, B, or C, right? If it matches with any of these, it will return pass instead. So even though there's no break here, it'll keep falling through. So in a lot of ways, this is like if the letter grade is equal to A, or the letter grade equals B, or the letter grade equals C, return pass. Return case D, case F is if the letter grade equals D, or the letter grade equals F, we're going to return F, and then the default value will just return U for an undefined grade. So sometimes you want that behavior if you want the exact same thing to happen for multiple values. Any questions here? Yes? Yeah, you do the string literal. It has to be a constant value over here. The other thing is there's two upper. The two upper function is in the ctype.h library. You give it a character and it gives you the uppercase version of that character. So if I do what? If I put like an empty line here, yeah, same behavior, right? The only thing that's going to kick you out of this, the case statement, is the B, is the break, right? Since there's no break, it doesn't matter how much white space is there. Remember, white space in C doesn't mean anything. Any other questions? Yes. The fall through? It's the default behavior for every language I've seen that implements a switch statement. You do not have to have a default case. It's optional. You might get some complaints from the compiler, though, if you don't have it. But it's not needed. So the question is, what happens if your value doesn't match any of your cases and there is no default value? So think about it, if you had a whole bunch of if, else if, else if, else if, else if, but no else. What happens if you don't have any match? None of them run, right? Nothing happens. Same thing would happen here. If there's no matches, you don't run any of the corresponding code, so you do nothing. Anything else? Okay, we will run our code. Oh, oops, wrong one. So again, I have to enter some colors. So I'm going to enter like 1 for yellow. So this first one that has breaks, it's like, oh, it's yellow, right? I'm going to just slow down. The piece of code that didn't have breaks, like I said, it's going to go through all the options because we just keep following through. And then we might have some letter grade, you know, got a P. So we fell through A, B, C, and we finally went and did it. Or if you want to see it run again with just like A for the letter grade, do that this time. For the letter grade, if we say that our letter grade is, say, A, right, it also says you have a grade of pass because A or B or C, we return P. Any questions before we get on to loops? So in the switch part up here, there can only be a single variable. So you want to check one variable against some other value. Anything else? Okay. So in C, there are like 3 types of loops. There's while, do while, and for loops. They're all really just basic versions of a while loop that you know from Python. So your while loops look like while, some condition, curly brackets, code that you want to run while that condition holds true. They behave just like the while loops that you've seen in Python. No difference. There's do while loops, which are do, curly brackets, some code, while some condition is true. The difference between a while loop and a do while loop is that in a while loop, the condition is checked at the top of the piece of code, and in do while, the condition is checked at the bottom of the code block. So a while loop is going to run 0 or more times, and a do while loop is going to run 1 or more times because the check is at the bottom. It always has to run at least once. Questions here? So if you want to do something 0 or more times while loop, 1 or more times do while loop. Then there's a for loop. And the for loop looks like this: for, initialization statement, some condition, and then an update statement. The code that you want to run while the condition holds true. Basically, the for loop is just a fancy version of a while loop. And the equivalent while loop looks like the initialization statement. You do it once. You do it once before everything else happens. You do it once before you check your condition. Then you start your loop up. While condition, the code that you want to run while the condition holds true, and then this would be the update statement. The update statement would happen at the end of the loop. So pretty much when you're writing your loops and you're actually iterating through things, you want to have some update statement and you need to have some initialization statement. We'll see some examples in a minute. So you can use for loops for doing while loop statements and while loop statements for doing for loop things. I still recommend following the advice that I give in like ECS 32A. Use for loops for when you're going through things, like the for each element, just like you do in Python, and while loops while the condition could last for an indefinite amount of time, while you haven't reached some condition, or until something happens. Use a while loop. The break and continue behave exactly like they do in Python, right? What does break in the loop cause you to do? Exit the loop, right? What's continue cause you to do inside the loop? Go back to the top of the loop. In Python, what's the difference between the continue statement in a for loop and a continue statement in a while loop? There is a difference. So in a while loop, where you hit the continue, what happens? You go right back up to the top, right? And you check your condition, and then you carry out with the code. When a for loop, you hit the continue. You go to the next element, right? You run that update piece of code, go to the next thing, and then you go back to the top of the loop. The same thing happens in C, right? If you have a continue statement inside a while loop, it just brings you right back to the top of where you're at, and you check the condition and keep going through if the condition holds true. For a for loop, you first run the update section of code, and then you go back to the top and check if the condition holds true. Does that make sense? Do you guys realize why that's very important? For example, we'll add another function here. We'll have a while continue. Void for continue. These things that I just wrote out, are they definitions or declarations? Declarations. If you write your declaration in C-line, you can have it generate the definition for you. So, we have int I while I is less than 10. If I equals 5, continue. Plus I. So you guys know plus equals, right? So plus is like plus equals, but it's always plus 1. So I plus is essentially equivalent to I plus equals 1. There is also an I plus plus. Plus I and I plus plus. This is called the pre-increment. This is called the post-increment. And really, as long as they're on a line by themselves, they're identical and there's no difference. The only time they behave differently is if they're used in a more complicated expression, and I recommend you never use them in a more complicated expression because it gets confusing. For example, if we do int a is equal to, so like int a equals 10, right, b equals 5. And I say a equals b, let's say 5 plus b plus plus, and a is equal to 5 plus b. These are what I recommend you never do. Don't do these things. Because they get confusing. So the post increment happens after the rest of the expression. So we're going to use the original value of b here. So on this line, a is going to be equal to 5 plus b, which is 5, 10, and then we would add 1 to b's value afterwards. Here we would do a is equal to 5 plus b. The plus happens first. So if you assumed b's value is still 5, we would do plus b. B is now 6. Then add 5, a becomes 11. It gets really confusing when they're in larger expressions, so just use them by themselves. No, you do not get the same result. In the first result, again, if we assume that, I'll make this actually legit, c is equal to 5. Here, a equals 10, b equals 6. Here, a equals 11, c equals 6. Because it has to do with when they increment. So the plus here gets applied after everything else is done. So we use the original value of b. So we get 5 plus b's value 5, store that result into a, get 10, then add 1 to b. But here, we do the plus first. So we add 1's result to c. C is now 6. Then we add 5, store that into a. A is 11. And this is why it gets confusing. And if you really want to mess with people, and again, I do not recommend you do this, but it's still syntactically legal. A is equal to B plus equals 7, plus B, minus, C mod equals 99. This is all legal. I don't recommend you do this because it's confusing. And you want your code to be clear and understandable. So when you're doing like the plus equals things or the minus equals things, just do plus equals, minus equals on the left-hand side. Don't use them in the middle of an expression. It's still valid. So what would probably happen is here is first we would add 1 to B. And then when we do this result right here, we would do what this expression evaluates to is we do we'll add 7 to B, and the result of that sum is going to be the result of the expression in parentheses. So whatever B's value plus 7 is would be coming out of there. Then we'd add that to like 1 more than B, and then we would take C mod equal 99, whatever that result is. Just don't do it. You understand why you don't want to do this? You may see code out in the wild that does this. It's confusing. Any questions here? No, I will not do this to you on a test. Don't do this to me on a test either. If I want to figure out if it's working or not. So again, like, you're doing plus, do it by itself. If you're using the other updating operators, plus. If you're doing the other updating operators, that's fine, right? Like, doing like A plus equals 7, plus B, that's totally fine and understandable, right? Everyone knows what that does? Take B's value, add it to 7, add the result to A, store the result back into A. Completely legal, completely understandable, that's fine. But don't get the crazy stuff. It's not any better than just doing it on separate lines of code where people can actually understand what you are intending to do. So here, if you're doing C-line, here's a cool shortcut. You can do Control-J or maybe like Command-J in Python or Command-J in Mac, and it'll give you this for, and then it'll write the for loop for me. So for I equals 0, and then I less than, again, we'll do 10, and we'll have this exact same piece of code here. Right? So the only difference is I use a for loop on one and a while loop on the other. What do you think is going to happen on the while loop? I mean, I'm assuming that we know, here we printf %d, I. We might want to do something like interesting here. Yeah, the while loop is going to go into an infinite loop because you just keep going right back to the top. You're like, oh, is I equal to 5? Yep, let's go back to the top. Oh, is 5 less than 10? Yeah. Is 5 equal to 5? Yeah, let's go back to the top again. Right? We're stuck in this little cycle, but it looks good. It looks like it would probably work. What's the for loop going to do? Oh, I guess I should also have said, for int I equals 0 up here. This will actually print out the values from 0 to 9, except for 5. Because when we hit the continue here, we run the plus I, and then we go and do the check. Make sense? Oh, questions? Mm-hmm. Well, again, like the value up here doesn't need to be constant. Like if you have a variable called length that has how many elements there are for I less than length, right? So you wouldn't ever do like an explicit constant like this for these two examples, and we'll show you some other examples of using loops in a second that don't use the hard-coded values. But I agree that Python syntax is a lot nicer. So here's an example of summing numbers while the user keeps entering positive numbers, and it uses a while loop and the break. So we enter a positive number to add a total, enter a negative to quit. We ask them for the number, we scan it in. If the number is less than 0, we break. Otherwise, we add it to the total, and eventually we'll return the total. right? So there's a while loop. Let's see. So this little piece of code right here counts how many digits there are in a number. So you give it a number and it tells you an integer number and it tells you how many digits there are. So I get the absolute value of the number. Absolute is in stdlib.h. And then so I do a do while. So I add one more digit because I've counted one more digit. Then I divide the result by 10, right? And then while that result is greater than 0, we keep going. For example, if I had like 99, if 99 divided by 10 is 9, well then 9 is still greater than 0, so we keep going. So we're going to add one more to our count to get to 2. 9 divided by 10 is 0. Is 0 greater than 0? Nope, so he stops, so 99 has 2 digits in it. Does that make sense? I'll run it through the debugger in a second so that you can see the value in a second. And then here's an example of printing the matrix. Obviously, for loops, if statements, everything can be nested just like in Python. So for the row equals the start value, row less than equal to end value, go to the next row, call equals the start value, call less than equal to value, plus plus call. We then print out the element followed by a space. Some new printf syntax, the star. So a number in front of the decimal means print out at least this many things. So if I did a 5 here, every time you print out a number, it would print out at least space for 5 characters. If your number was shorter than 5 characters, it would print out spaces instead. So like if your number was like 30, you'd get space, 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 30. Does that make sense? The star here means look for this value in the argument list over here. So I'm going to print out however many the maximum number of digits there are. I want to print out at least that much space. And then I'm going to print out my value, row times call. So for example, if we did something like a 12 by 12, we're printing out the matrix, right? The biggest number you get is 144, right, for 12 times 12. So 12 times 12 has 144 has 3 digits in it. So num digits would have the value 3. So you print out at least 3 spaces worth. So it looks very nice as it comes out. If your example though, you're only going up to like a 5 by 5, you'd have 25. 25 only has 2 digits, so you'd print out at least 2 characters worth of space every single time. Does that make sense? So wait, what did I want to show you? There's a breakpoint in here. So we're going to make a 1 by 12 guy over here. So again, 12 is 144, so our number is 144. So we add 1 to our count is now 1. 144 divided by 10, 14. 14 is greater than 0, so we add one more to we're going to add 1 more to our count, so we get 2. 14 divided by 10, 1 greater than or equal to 0. Yep. Add 1 to our count to get 3. Divide 1 by 10 to get 0. 0 is not greater than 0, so the number of digits in here is 3. Make sense? And so if we keep going, you can see here's a very nice, beautiful matrix where everything's all lined up for your table. And now if I keep entering in numbers and then finally do a negative number, it stops, and the sum of those numbers was -8. Ooh. Segmentation faults. Is it a segmentation fault? Let's run it. Okay, no, it was not a segmentation fault. It was just finishing up. Kind of would be confused for a segmentation fault because the only time it can happen is right here. Anyway, any questions about loops? Yes. So the question here is in this statement right here. Doesn't matter whether it's plus plus whatever or the thing plus plus. It doesn't matter because again it's by itself, right? This piece of code runs in isolation from the condition and the start value. So plus plus row plus plus, same thing. Gonna be no difference. Any other questions? Okay, we will now do something useful with our newfound knowledge. So you might be curious about how does input validation work in C? How do I make sure that you entered in the things that I needed you to enter, right? And you didn't enter in garbage. Or if you entered in garbage, how can I clean that up, right? Pretty useful thing to know. So the first thing that I need to let you know is that scanf does return something. It returns how many of the format's placeholders it was able to fill in. So whatever. You might have something like right, so we might have something like so we wanted the user to enter something in as number, comma, number, right? So what scanf is going to do is going to tell you how many of the format placeholders it was able to fill in. So here we can either fill in 0, 1, or 2. It's going to tell you how valid it is. For example, if you entered in something like this, what do you think args red is going to be? 0, right? Because you're going to try to match the %d against, Catman. It doesn't match, and so you would skip over it, and you wouldn't read anything. Args red would be equal to 1, because you can match the 3, right? One, because there's no comma. Argus red would be 2. Argus red would be equal to just 1. Argus red would be 2. Does this make sense? So our goal for figuring out if input is valid, what would you state it as in English for the input to be valid? So yeah, in this case, we need to read in two things. It needs to be number, comma, number. But in the general case, for input to be valid, yeah, so the number of arguments read needs to be equal to the number of things that I need, right? And what's the last thing? Well, the args read won't be equal to the number of args needed if the types don't match, or if it's not able to scan it in. So that covers the typing as well. There's one other condition. That would be num read equals num needed. And there's nothing left, right? You need to give me everything that I asked for, and there needs to be nothing left. So we want to write a function that does that. So args needed. Does that make sense? Okay, guys, you're on the spot. How do we implement that? So the user will attempt to call this function after they've made their scan. So they will have called, like, they're going to do something like this. Like, oops, I want to define this. They're going to do something like this, like do while not is input valid. Args read, and how many do they need? How many do they need in this example? 2, right? So this is our structure code. So they're going to read it first and then call it. Yeah. It's close. You're very, very close. There's a small mistake in that. And it happens to do with, what if there's leftover crap? Right? Because if you just do that right now, right, you've read it in, and now you need to double check to see that there was nothing. You haven't checked that there's nothing left yet. Yeah. Close. But there needs to be a bit more than that, because how many characters can be at the end? A lot, and we probably want to get rid of them too. Yeah, but we want, so after we kind of do this, we also want the input to be set up to read the next argument. We don't want to leave the other crap there if it's still there. The other issue that your statement has is that C, like Python, uses short circuit logic. And so if the first expression evaluated to false, we wouldn't do anything to the right of the and sign, right? Because if you do false and stuff, right? False and stuff and stuff and stuff and stuff, that's always going to evaluate to be false. So C, Python, they won't bother evaluating the thing that comes after the first false. No, a single ampersand doesn't mean keep going. Single ampersand is bitwise and. You're checking the bits individually, which you probably do not want to do in this class. Yeah, the first thing that we should check, though, is not whether we've read everything that we needed, but that there's nothing left, right? We need to check that there's nothing left first, right? So we might have something like bool, nothing is left, equals is nothing left. Or, we might have it something like this, return nothing left and args read equals args needed, right? We like functions, we'll write more, right? So bool, nothing left. Okay, so how can we check it that there's nothing left? Like, you can't do the Unix wildcards, and no, it doesn't work. Yeah, how do we do that? That would be the command line argument, which is not the same thing as the standard input, which is what we're checking right now. But close, but not quite. Because one of the issues with scanning the string is you have to have enough space to store the string. I don't know how much stuff could be there. I don't know how much space to pre-allocate. Yeah, and what character we're kind of looking for. Or like a new line, right? I'll keep reading and see if there's a new line. But we can allow white space at the end if we want to, right? So we might have something like a char, you know, input char. And we might say do scanf %c into input char. Do I want a space in front of the %c here? Yes, space in front of the %c? No, space in front of the %c? So what would a space in front of the %c mean? One or more white space characters, but do we want to be able to read white space? Yes, we do. We want to be able to read the white space here. So if we put the space in front of it, it would require me to read a non-white space character, which means there would need to be crap afterwards. So we read in one character, and so what should we do? What character we're looking for? Right, so if, oh, this is probably not going to be, you know, need one more thing, bool, there is nothing left equals true. So we're going to assume that there's nothing left until we find otherwise. So is space can be used to check if a character is a white space character or not. So if it's not white space, input character, what should we do? There is nothing left should become false, right? And then, or maybe you want to do like this, like if input char equals a new line, we can just break. Else if it's not a space character, we're going to make it equal to false, and we need to include C type H. So any questions on this function? And there's a very key subtlety about this function. Oh, oops, we forgot to do something. Return, there is nothing left.
Why is this variable that would store garbage value? And why is it?
Because integer only matches with integers, but a character can match with anything, right? Because like the number 1, could you interpret that as a character? Or 2 or 3? Like the number 123 is the character 1 followed by the character 2 followed by the character 3. So that's why we need to do a char here, because if we did %d or %elf, it wouldn't be able to match. So let's think about that example. So we read our first character. It's a white space character. Is it equal to a new line? No. Is it equal? Oh, actually wanted to do this. Hold on 1 second. Do while input character doesn't equal a new line, because there always has to be a new line at the end. So again, we read a character as a white space. So it's white space. So we go into this if statement. Will we go into it? The if statement. No, right? So it stays as good. So white space, like your space is not equal to a new line. So we come back up to the top. We read in the next character, it's garbage. So is garbage a white space character? No, it's not white space. So we're going to go into this loop and we're going to change to be there is nothing left to false. Okay. Right? And so it's going to stay as false forever. And we're going to keep reading all the characters until we reach the new line. And that's really, really important. We keep consuming all of the input that the user happened to enter after what was valid or whatever just happened to be entered there. So if the user did enter something like Catman back here, well, we won't be able to read anything up here. But then when we call nothing left, he's going to keep reading. Read. Everything until Catman's all gone, and so the user can now enter in new information. I think depends on how it's encoded, but if it's like it's encoded as multiple bytes, you'll probably still wouldn't work. But I haven't tried it with non-ASCII. What doesn't like about this? args red, thank you. Or args red equals args needed, I don't know. Any other questions? So this is how you would do input validation in C to guarantee you're getting what you want. And so like your get chord would say something like, like printf right? We read in the character, we then double check that everything's good. If it's bad, we're gonna go do it again. Does it make sense? Any questions here? This is something that takes people forever in 30 to understand. This is now on the Google Drive right now. Yes. Hold on, guys. Be quiet. We've got 4 minutes. That's a lot of time. So the question is, if we did like Catman space 3, 4, would that work? No, it would not, because up here we would attempt to do the scanf, right? Args red would not be equal to args needed, right? We wouldn't be able to scan in the Catman part. And then so we would go and find that there is indeed stuff left, right? And so this expression would evaluate the false. So no, it wouldn't work with Catman some numbers.
Given that, why would it work? Why would double that make?
Oh, so like your question is like when we did 35.26. So how much of this matches with %D? Just the 35. And so we read the 35 and we're left with 0.26. Does 0.26 match with %D? No, so we won't be able to read one thing. Let's keep going. We have 3 minutes. Why is this over here? Why am I up there? Okay. Talking about arrays now. So arrays are like Python's lists, except they suck. Pretty much like how you're probably going to feel about C everywhere else. Okay, there we go. So the syntax for declaring an array, syntax for declaring an array is the name of the type, your variable name, bracket, and then how many elements you want, the maximum number of elements you're willing to hold. This number needs to be known at compile time, so it has to be a constant value. So unlike Python's list where you can do mixed types, C's arrays, all the types have to be the same. So you can have arrays of integers, array of characters, array of doubles, array of floats, but not an array of integer floats or something like that. All have to be the same type. This number has to be known at compile time, and you could not return one of these statically defined arrays from a function. It will not work. So you can't return these arrays. But you know in Python, if you had a list and you mutated the list, like if you changed an element of that list inside the function, what would happen to the value outside the function? It would change as well. You get the exact same behavior here with C's list. If you edit the element of a list inside of edit an element inside the array, inside a function, the change shows up outside as well. Finally, there is no like len on C's list. So you have to keep another variable around for each array that keeps track of how many things you actually have in it. Which is annoying, but has to be done. So here's an example of find, where we want to find a value in an array. I don't know why it keeps changing my types here. So we have our value array. We go through each one of the elements of the array. You index them just like you do in Python. If the value matches, we return the position. No matches, we return -1. We will continue talking about arrays, the static arrays that you're seeing here, and dynamic arrays, pointers, next week. Yeah.
I submitted code to CodeCom. It tells me everything's all good, all correct, but then it says 0 out of 100 for score.